Hi, everybody. Today we are going to look at Planck's equation using Planck's constant. And so let's review a few parts of this equation. So first, we have energy, capital E. The unit for energy is joule with a capital J. Planck's constant is 6.626 times 10 to the negative 34th joules times seconds. And then the frequency, symbolized by V, the unit is usually hertz. Okay, so we're going to go through and do a few problems with all of these variables and units. So here's an example for the first problem. Determine the energy associated with a frequency of light that is 5.6 times 10 to the 15th hertz. So first thing I want you to ask yourself is, what is the problem asking you to find? What does it ask for? So go back to the beginning. It says determine the energy. So energy, or E, that is what we are solving for. What does the problem give you? Well, we look at the other part of the problem. It says a frequency of light that is, okay, so it's telling you this is the frequency, 5.67 times 10 to the 15th hertz. The other thing that tells you this is frequency is the unit. We know that the unit Hz means hertz. So we know that 5.67 times 10 to the 15th, that is our V value. That is our frequency. And then what do we already know? Well, if I look back at the equations that we've talked about so far, we have this one, which is C equals wavelength times frequency. And then we have this one, E equals H times frequency. Well, since I'm looking for energy and it gives me frequency, it looks like I should use this equation, right here. And so I already know that the value of H, because it tells me up here, my H is 6.626 times 10 to the negative 34. Okay, so since I know H and V and I'm trying to find E, I'm going to plug them into this equation. So to find E, I'm going to have to take 6.626 times 10 to the negative 34. The unit is joules times seconds. And then I'm going to multiply that by the frequency, which is 5.67 times 10 to the 15th. Now, we used hertz here, but remember, hertz is the same thing as 1 over second. The reason this is important is because this second and this second will cancel out, which is why the energy unit for this is going to be joules. So now I'm going to take my calculator and I'm going to enter my value. So I'm going to say 5.67 E15 times Planck's constant, 6.626, E negative 34 equals. And then it gives me an energy of 3.76, I'm going to round that, times 10 to the negative 18th joules. Okay, so that is my answer to the first problem. Okay. So now let's move to the second problem. So the second problem asks us to determine the frequency of light given an energy of 5.90 times 10 to the 18th joules. So first, what does the problem ask for? It asks for frequency. And what does it tell me? It tells me the energy. And then what do I already know? I already know H is 6.626 times 10 to the negative 34. Okay, so now this time, if I put all of this in this equation, I'm going to put my E on this side, because that's where E is, times 10 to the 18th. I'm going to put my H on this side. And then I want to find V. Well, in order to get V by itself, I'm going to divide both sides by Planck's constant. Okay, when I do that on this side, they cancel, so my frequency will be the result of me dividing this. So I'm going to take 5.90 E18 divided by 6.626 E negative 34. It's going to be a really big number. And that is because I did not use negative 18 up here. I used positive. Whoops. 8.90 times 10 to the 51st. Yikes. Hurts. Okay? But that is the answer. That is the correct answer based on the numbers given. Okay, now let's look at the next problem. The next problem uses both equations, and that can happen because if you will look at the overlap between your equations, the only thing that both of these equations have in common is frequency. They both have frequency. So we're going to use that to our advantage. So in this problem, it asks for wavelength. Okay, it wants to know what is the wavelength. But it gives me energy. Okay, so what do I already know? I already know two things. I know H is 6.626 times 10 to the negative 34. I also know that C is 3 times 10 to the 8th. So those are the things I already know. Now I need to look at my equations. I cannot solve for this one yet because even though I know C, I don't know this and I don't know this. So if I have two variables I don't know, I cannot solve for that equation yet. Now let's look at our other equation. I do know E. I do know H. I don't know V. So I can use this equation. So we're going to do this one first. So I'm going to use this one, and I'm going to say 9.75 times 10 to the 18th equals 6.626 times 10 to the negative 34 times frequency. So once again, I'm going to divide by H to get the V by itself. And whatever I do to one side, I have to do to the other side. Okay. Once again, I'm going to get a really big number here. So my frequency is 9.75 E18 divided by 6.626 E negative 34. Oops, let me go back. 626. So I need to insert a 2 in there. Okay, now I can hit enter. All right. So my V for this is 1.47 times 10 to the 52nd. Okay, and then my unit would be hertz. Now, so this is my V. Well, now it really wants to know wavelength. So now I have enough to solve this problem. Now that I've done all of this work, I can erase this just because I don't have enough room. You don't have to erase it if you have plenty of room. And now I'm going to use this equation. I'm going to use my C equals wavelength times frequency. So I have C equals wavelength times frequency. So I know my C is 3 times 10 to the 8th. I don't know wavelength yet because that's what I'm trying to find. And I know my frequency is 1.47 times 10 to the 52nd. Once again, really big. So I'm going to divide both sides by this to get wavelength by itself. Then these guys will cancel. And then my wavelength will be my result here. So we would say 3E8 divided by 47 E52. So I would get 2.04 times 10 to the negative 44 meters. Okay. All right. Last one. We're going to do one more. This time it's going to give me wavelength. And it's going to ask for energy. So the problem asks for energy. It gives me wavelength, 435 nanometers, which is this. And I already know H. And I already know C. Okay, well, in this case, I'm going to look at this equation first because I know C. And I know wavelength, so I can find frequency first. So that's what I'm going to do. So I'm going to say 3 times 10 to the 8th equals wavelength. Now remember, whenever you have wavelength and it's given in nanometers, you need to say times 10 to the negative 9th. So I'm going to say 435 times 10 to the negative 9th times V. Okay, so I'm searching for V. I'm going to divide both sides by my wavelength to get V by itself. So this cancels and this cancels, so then my V equals that. So let's look and see what it says. So 3 E8 divided by 435 E negative 9. And that gives me 6 point, we're going to round it up to 90 times 10 to the 14th. So that is my frequency. So then if I want energy, I can use this equation. So my energy equals H, which is 6.626 times 10 to the negative 34, times my frequency, which I just found is 6.90 times 10 to the 14th. So then you're going to multiply these together. So I already have my answer from the other one, so I'm going to multiply my answer by 6.626 E negative 34. Oop. And then my answer is 4.57 times 10 to the negative 19th joules. Okay, so give your problem set a try, and then we can go over some questions or any questions that you have next week. Thanks, guys.